This is the third of a series of videos on isosceles triangles, and in this video we're going to prove the isosceles triangle theorem. But before we start, we need to think about two concepts. The first one is the idea of an angle bisector. And what an angle bisector does is it cuts an angle in half. And the key thing is you need to know is that every angle can be bisected, and it can only be bisected in one way. Seems to make sense. And the second concept we need to know about is something called CP-CTC. And that stands for the corresponding parts of congruent triangles are congruent. And we just call it CP-CTC as an abbreviation. And if you think about it, that's exactly what we mean about when angles are congruent. Triangles are congruent. Triangles are congruent if the corresponding parts are congruent. So let's go and get started. And the first thing we need to do is we need to start with a triangle. And so let's just draw a triangle out. And it doesn't really matter how you draw it. And let's call this R, S, and T. And the given is that RS is equal to RT. So if you think about statements and justifications on a formal two-column proof, the very first step here would be that RS is congruent to ST, and that's the given. Now the first thing that we're going to do here is we're going to draw in an angle bisector. So we're going to draw in a line SX so that SX bisects angle S. So we're going to draw SX to bisect angle, and to be precise, we're going to call it angle RST. Well, then our next step is that angle RSX is congruent to angle TSX. And the justification there is the definition of an angle bisector. We say that an angle bisector bisects an angle. Therefore, the two parts are equal. So that's just definition of angle bisector. Now the next step that we're going to do is we're going to say that side SX is congruent to side SX. And that's true because everything is always equal to itself. And that's called the reflexive property. Now if you don't remember this called reflexive property, then it might be enough to say that sides are equal to themselves. That's all the reflexive property is. And now we might just want to take a break for a second and see where we are. Now we have two triangles here, right? RXS and XST. And it's given that RS and ST are equal. And it's given that SX and SX are equal by the reflexive property. And we know that this angle and this angle are equal. If you notice here, then therefore we know that these two triangles are equal by SAS. So let's just write that down. We have triangle RSX is congruent to TSX. Now be careful when you're writing the congruent statements. When you write the first part of the congruent statement, it doesn't matter how you write it. You can write it in any order. But then the second one has to match. So notice here that R and T are congruent. And we know that S and S are congruent, and we know that X and X are congruent. How do we know that? That's called the SAS congruence theorem. And this is where we kind of have a new tool to prove things. We know that if these are congruent triangles, then the corresponding parts are equal. Well, angle R corresponds to angle T, therefore you know that those have to be equal. And that's the last step. Angle R is congruent to angle T, and we just abbreviate that by CP, CTC. Corresponding parts of congruent triangles are congruent. And then we're done. I'm not sure if they still do that, but back in the day, whenever you were doing with the proof, you would say QED, which means that which was intended to be demonstrated has been done so. And we're done.